Solving simultaneous linear equations algebraically. Alright, so when solving simultaneous equations algebraically, there are two methods that we use, substitution or elimination. We're going to investigate both throughout these slides. So the first method is substitution. Now, substitution is useful when a linear equation or the linear equations are in the form like this here, where we've got one variable on one side of our equal sign, a constant, another variable, and then another constant. All right, so it's useful when we've got a variable on either side of that equal sign. So, example, solving simultaneous equations by substitution. All right, so first up, we have got our two linear equations. Just here. So the first step would be to number each of our equations like so. So our first equation is y equals 5 minus 2x, and our second equation is 3x minus 2y equals 4. Now, what we want to look for here is when we're doing substitution, we want to look to find one of the equations where the variable is equal to something. So as you can see in our first equation there, y is equal to 5 minus 2x. What we do in substitution is then we take this known variable and we sub it into the other linear equation. So we're going to take y, which is equal to 5 minus 2x, and sub it into y here. And you're going to have it look like this. When we write out, we have our second equation, we have 3x minus 2, and in the space of y, we're actually going to sub in our y up here. So we get 5 minus 2x equals 4. From here, we're going to work through and expand our brackets. So we're left with 3x minus 10 plus 4x equals 4. Simplify that down, we get 7x minus 10 equals 4. We're then going to add 10 to each side because we are trying to get x on its own here. From there, we are left with 7x equals 14. Then we want to get x on its own. We're going to divide both sides by 7, and we're left with x equals 2. So we've found the value of x. Now we need to find the value of y. So we're going to sub x into our first formula. All right, so this formula here. So we're back to where we started. So we found that y equals 5 minus 2, and we know that x is equal to 2, so we're going to sub that in, times 2. So y is going to be 5 minus 4. So y is going to equal 1. So we're left with x equals 2 and y equals 1. We've solved our linear equation by substitution. So key points for this are, first you need to find or have one of your linear equation where a variable on its side on its own equal to something else. All right. We then sub that into the other equation like we did. We had y. We sub that into y of our second equation and solve for x. When we found x, we subbed x back into the original and found y. And we were left with x equals 2 and y equals 1. Okay, so method 2, the elimination method. So this method involves adding or subtracting the linear equations together. It can be a little bit more challenging, but let's have a look. Alright, so solving simultaneous equations by elimination. Solve the pair of simultaneous equations, x plus y equals 3 and 2x minus y equals negative 9. Now you'll see that in contrast to the example where we use substitution, the variables are on the side together and they're the same variables. All right, there's a key thing to look out. So like with the substitution, what we want to do first is number our linear equations 1 and 2. So we're left with our first equation, x plus y equals 3, and our second, 2x minus y equals negative 9. From here is probably the most difficult part of solving linear equations, is you need to look and see if we add these or subtract these, we want to try eliminate one of the variables. Right? So if we add them, will it work? Or if we subtract them, will it work? For this one, by inspection, and you'll come to be good at this, we can see that if we add them, we're going to eliminate y. To do this, I like to stack them on top of each other. X plus y equals 3 and 2x minus y equals 9. Now we were adding them together because we saw now you can trial and error these to see which one eliminates, but we were going to add them, so I like to put a little addition sign there. And let's add them. And just like we do for column addition, we are going to do the same here. So 2x and x, we get 3x, positive y plus negative y. This is where we see that elimination of one of the variables. Because if we take these, plus y minus y, well, we're left with 0, aren't we? Right? It's a bit like if we've got 1 minus 1, we get 0. So we leave that, they're eliminated, and then we go 3 plus 9 is 12. Right? Next we need to solve for x, and so we're going to divide both sides by 3. X is going to equal 4. So we've solved x, but we still need to find y. What we do from here is we sub our value of x into our first formula, like we did for substitution. All right, so we are left with, if we take this, x plus y equals 3, sub x in, which we just found, not 3, we'll try 4. 4 plus y equals 3. We need to get y on its own, so we're going to take 4 from both sides. Y is going to equal negative 1. So we've found x and we've found y. We've solved our simultaneous equations by elimination. So when we're solving simultaneous equations by elimination, we don't always, or we can't always just add and subtract those two linear equations to solve them. Sometimes we need to multiply them by a certain number so that we can add or subtract them to eliminate one of the variables. For instance, let's have a look at this one. Solve the pair of simultaneous equations. 3x plus 2y equals 2.3 and 8x minus 3y equals 2.8. Right? As you get better at this, you'll be able to see that by inspection you can't add or subtract these to eliminate one of the variables. So let's work through this. First, we write out our equations. Now we need to see what can we multiply these two linear equations by, so that when we add or subtract the variables, we will eliminate one. So if we multiply both by this one by 2 and this by 3, so they don't need to be the same multiplication. We multiply the bottom one by 2 and the bottom one by 3, and the top one by 3 rather. I'll show you what we get. So 3x times 3, we get 9x. 2y times 3, we get and our second one, 8x times 2, we get 16x minus 6y equals 5.6. Now we are going to number those as equations. That's equation 3 and equation 4. Nice. Now we can see that if we add these two equations, or can you see that these two variables are a positive and a negative? If we add these two equations together, we're going to eliminate the y. Right, so let's do that. Now I like to just go and plus them straight together. So we are getting 25x, these are eliminated, equals 12.5. Now, the 25 is multiplying x, so we're going to divide both sides by 25 to get x on its own, so we get x is equal to 0.5. So now that we've found x, we then take it and we substitute it back into our first formula like we have been doing previously. And we use that to find y, so let's write out 3x plus 2y is equal to 2.3. Sub our x value in, 3 times 0.5 plus 2y equals 2.3. 1.5 plus 2y equals 2.3. Subtract 1.5 from each side. And we get y equals 0.8. Divide both sides by 2 to get y on its own, 0.4. So we're left with x equals 0.5 and y equals 0.4. So from that, we learnt that sometimes you may need to multiply your equation so that you can eliminate one of the variables by addition or subtraction. It doesn't have to be multiplied by the same. As you can see up here, we did multiply by 3 times by 2 so that we could take eliminate our y variable.